Hi, I'm Brian Luck, Assistant Professor and Extension Specialist in the Biological Systems Engineering Department at the University of Wisconsin-Madison. Today I'm going to talk to you about precision ag technologies and the fact that we need to use what we already have when producing grain in low margin years. So investment in new technologies is probably not the best thing to do when profit margins are tight. There's a steep learning curve. You can develop quite a bit of frustration working with these technologies, and it can be sort of a time sink when field operations are pending, not to mention the cost of the technology itself. What we can do, though, is use and access existing technology to our advantage. So the first thing I'll tell you about is your smartphone, the device you carry in your pocket. There's a lot of neat things on there that can be used to accomplish some precision ag tasks. First off, you can utilize the GPS receiver on your smartphone for several typical ag applications. So the accuracy on the GPS receiver is not the greatest. It's plus or minus 10 to 15 feet. But if we're looking at soil sampling or field scouting or record keeping of that sort, we can do a lot of that stuff. So mapping field boundaries, marking areas of interest, or even grid and zone soil sampling. Most of these applications are free. They usually require an online account for accessing the data, and sometimes some more features can be obtained by a small fee. I listed some examples here, not endorsing any of these, just a few that are out there. Connected Farm Scout from Trimble. Cirrus has the SST software, and then the Ag DNA app as well. One of the first things we can do with this, since we all have perfectly square fields, we don't really have any trouble mapping field boundaries, which is not the case, obviously. But using your smartphone to map a field boundary is not the worst thing in the world. You can identify areas such as buffer strips and grass waterways that don't need any application during the growing season, and we want to maintain those areas to minimize environmental impact due to production. So looking at some of the other technologies that are out there, looking at pesticide and nutrient application, you may not have this technology, but you may be able to access it due to a co-op doing custom application or things along those lines. One thing I'll bring to your attention is using automatic section control on your spray boom. So just looking at point rows, end rows, and grass waterways and buffer strips that we do not want to spray. Looking at an 80-foot boom, which is really fairly small now compared to some of the booms we have in the state. If you just shut the whole boom section, entire boom off as you enter a point row, you overspray about 720 square feet. Dividing that into sections, if you look above 5 sections or above that 7 sections, you decrease the amount of overspray pretty substantially. So being able to use those saves on chemical and reduces application error, obviously. Again, the other thing is maintaining our environmental structures, buffer strips, grass waterways, things along those lines. When the nozzle is shut off, you don't eliminate those areas, and we minimize our environmental impact and also maintain reduced soil runoff. So another thing with automatic section control that I've been talking about for a little while is that our applications vary due to turning and variations in boom pressure. So 25 to 36% of these fields receive the prescribed application rate. So something to think about when using that automatic section control is to minimize turning and make as many straight parallel passes as possible, and then it does speak to the benefits of variable rate application just for maintaining a constant application rate. The goal of that obviously would be to minimize chemical usage to essentially save you money on that end. Another thing we'll talk about that you may have access to is the dry nutrient application with spinner spreader, which has on-off capabilities and variable rate control as well. The variable rate's important due to the fact that some areas of the field you may find doesn't need the chemical or the fertilizer application, whereas the on-off capabilities minimizes over application in headlands and point rows. So I have a quick example that I talk people through, which is we worked with a field in Dunn County. It's a 120 acre field, and we had 1 acre grid soil sampling on that field. This was going to do for a lime application, so we wanted to put on the proper amount of lime. Initially, we didn't get the variable rate application map done in time, so in the spring, 2 tons per acre were applied. That cost at the time $26 per ton, so the total cost for that was $6,240. Soil sampling on the 1 acre grid showed variation from 0 to 15 ton per acre. I know we're not going to put on 15 ton per acre, so we assume about a 6 ton max, or in this case we actually went to a 5 ton maximum application. So everything got 2 tons per acre, and then we're going to aim for the middle and apply 3 tons additional application. That's going to be our maximum. Let's assume that we applied that to the entire field. It would cost an additional $9,360. That's quite a bit. If we look at the variable rate, it came out to be an average rate of 1.57 tons per acre over that field, with some areas getting 3 tons per acre, others receiving 0. So we applied 188.33 tons, costing $4,897. That was a difference of $4,463. So we actually saved that amount of money by not applying the 3 tons per acre uniformly across the field. When we go back and do soil sampling for pH again, this year and next, we should show less variation in soil pH as well, which will be a good thing and mean less will need to be applied in the future. So another example of using technology is one where if you do have a corn planter with row shutoffs, then you can utilize that to save on seed. So if we have a theoretical 12-row corn planter on a 30-inch row spacing, and we have a perfectly square 1 acre field, it takes about 7 passes to get over that with the planter. So we plant in the first row end row every time, assuming that we go in 30 inches on a square headland turn. How much do we overplant? If you look at it, it's about 1,044 square feet overplanted, and that's 0.024 acres. Again, a perfectly square field, and I know we all have those. So when you multiply that over 100 acres, say, of perfectly square field, we overplant 2.4 acres, and that's starting to mean something now, right? So what I've done here is calculated essentially the amount of seed wasted, which is about 2.4%, and then if we assume $230 a bag of Roundup Ready seed, which may or may not be accurate, you're looking at about $5.52 per acre that we've wasted essentially in seed alone. Now, that's not necessarily, all that's doing is calculating the price of seed that we overplanted. What happens when we double the yield, or double the plant population? What happens to the yield in those end rows? Anybody will tell you if you double the plant population, same amount of nutrients, yield is going to go down. So we're actually losing yield on that end as well. So utilizing row shutoff in a planter will actually save you money on seed as well as yield in the end of the year. Finally, I want to talk about auto steer and guidance. A lot of machines have this on it now, and if you use it, you can save a little bit of money. So utilizing auto steer navigation could provide net returns up to $3.35 per acre, according to Shockley in 2011. What this does is it reduces overlap and skipped areas in the field, saves on input costs, and minimizes the input to crop yield. It also maintains pass-to-pass widths, which minimizes field operation passes, and that saves fuel. One study I saw actually said over an 80-acre field, they did it with auto steer, and then they tilled it again with just human operator, and there was 5 passes difference between the two. So the automatic guidance saved 5 passes over the field, which is quite a bit of fuel. The other thing to think about is operator fatigue is reduced when you use auto steer. So once you trust the auto steer system, you can work a little longer to hit the operation window, so you're not as tired, and you can also pay more attention to the implement rather than steering the machine, which you're going to minimize the effect of clogged seed tubes or anything that's going wrong back there on the implement doing the operation to the field or the crop. So with that, I'll end my video, and there's my contact information. Feel free to contact me.